Welcome to the investigation, where every rock layer is a clue and every mass extinction is a planetary crime scene. Before you are rocks that tell a story of a world bursting with life, a planet dominated by strange, powerful creatures that were not dinosaurs, but something far older. Then, in a geological instant, the story stops. The book of life is slammed shut, its pages scorched, its characters erased. Ever wonder what it truly felt like to be the first detective on the scene of a 252-million-year-old apocalypse? So, before you get comfortable, take a moment to like the video and subscribe. But only if you find the investigation we're about to undertake is a valuable one. Tell us where you are watching from in the comments, and let us know which global cataclysm you want us to investigate next. Now, let's open the case file and uncover the story of a lost world. You're kneeling in the dust of the Karoo Basin in South Africa, the sun beating down on a vast, silent landscape of layered rock. Your hand traces a line in the strata. It's unassuming, just a subtle shift in color and texture. Yet this is the most critical crime scene in Earth's history, the Permian-Triassic boundary. Below this line, the rock is a library of a lost empire. You can practically feel the thrum of its ecosystem. Fossils tell of a world ruled by the synapses, our own distant cousins. Imagine vast herds of pig-like Lystrosaurus and bulky, tusked Dicynodonts stripping vegetation, stalked by the apex predators of the day, the Gorgonopsians, saber-toothed proto-mammals the size of bears. This was a stable, complex world that had thrived for millions of years. Then you move your fingers just a few centimeters up, across that boundary line. Silence. The vibrant ecosystem vanishes. The rich fossil beds are replaced by what paleontologists call a fossil desert. The rock layers above the line are stark, barren, recording a world of ruin. The masters of the Permian are gone. Almost everything is gone. It's not just an extinction, it's a planetary sterilization. In the oceans, 96% of all species were annihilated. On land, 7 out of every 10 vertebrate species disappeared. This event is called the Great Dying for a reason. Looking at this silent line in the rock, you realize you're not just investigating the death of a species, but the near death of life itself. The central question of this case looms larger than any other. What kind of killer is so thorough that it can erase an entire world? To answer that question, you must first reconstruct the crime scene. Not just the basin where you kneel, but the entire planet as it was 252 million years ago. You pull your focus back, leaving the rock face to see the Earth from orbit. It's an alien world. All the continents you know have been crushed together into a single, colossal landmass that stretches from pole to pole. Pangaea. This C-shaped supercontinent cradles a vast sea, the Tethys, while the rest of the planet is covered by one immense ocean, Panthalassa. There is no Atlantic Ocean, no India crashing into Asia, just one land, one sea. This planetary arrangement creates a climate of extremes. The interior of Pangaea is a continent-sized desert, an arid wasteland under a relentless sun that makes the Sahara look like a garden. Temperatures here could soar to unbearable heights. Yet, along the coasts, this aridness gives way to the most powerful monsoons the world has ever known. For part of the year, torrential rains drench the land, feeding vast river systems and lush forests of giant ferns and hardy conifers. This is where life thrives. You zoom in on the southern plains, the same ground you stood on moments ago, but now it's alive. Great herds of Dicynodonts, barrel-bodied herbivores with turtle-like beaks and tusks, move across the landscape. They are the bison, the wildebeest of their time. You see sleek, powerful predators moving through the scrubland. These are the Gorgonopsians, the apex killers of the Permian. With skulls armed with enormous saber-like canines, they're a terrifying fusion of wolf and tiger. They are not reptiles, and they are certainly not dinosaurs. They are synapsids, the dominant dynasty of the Paleozoic era, and part of the same great lineage that would eventually lead to mammals, to us. For tens of millions of years, their empire has been absolute. In the oceans, life is equally rich. Trilobites, ancient arthropods that have survived for over 250 million years, scuttle across the seafloor. Reefs, built not by modern corals, but by other strange organisms, teem with fish and coiled ammonites. This is a mature, stable world. It is not fragile. It is not teetering on the edge of collapse. To bring this world to its knees would require a killer of unimaginable power and planetary reach. With a clear picture of the world that was lost, you now turn to the physical evidence contained within that thin boundary layer. This is the forensic analysis, the part of the investigation where the rocks are forced to confess their secrets. You take samples from the strata and place them in a mass spectrometer. You're looking for a very specific clue, the ratio of two types of carbon, the heavier carbon-13, 13C, and the lighter carbon-12, 12C. Life prefers to use the lighter 12C, so coal, oil, and methane are all heavily enriched in it. Your results come back, and they're shocking. Just before the boundary, the ratio is stable. Then, precisely at the line of the extinction, the amount of 13C plummets. This is a negative carbon isotope excursion, and it is the planet's toxicology report. It's an unmistakable chemical fingerprint showing a colossal injection of light, organic carbon into the atmosphere and oceans. Trillions of tons of it, released in a geological flash. This single clue changes everything. It tells you the killer was not slow or subtle. It was a sudden, world-altering event tied to a massive release of greenhouse gases. The investigation deepens as you examine the composition of the boundary rocks themselves. In many places around the world, from China to Italy, the limestone and sandstone of the late Permian give way to a layer of dark, finely laminated black shale. Running your fingers over it, you can almost smell the sulfur. These shales are packed with organic matter and pyrite, or fool's gold. They could only have formed in a dead, stagnant ocean, completely starved of oxygen. This is evidence of global anoxia. The oceans suffocated. Warming from the greenhouse gases would have stalled ocean circulation, turning vast swathes of the deep ocean into a toxic, oxygen-free soup. Finally, you analyze the fossil record for what isn't there. Just below the boundary, you find abundant evidence of shell-building organisms, brachiopods, corals, and fusulinids. Directly above it, they have vanished. The spike in atmospheric carbon dioxide didn't just heat the planet. It dissolved into the oceans, creating carbonic acid. The water became corrosive. For countless marine creatures, building a protective shell of calcium carbonate became impossible. It's like trying to build a house out of sugar in the pouring rain. You now have the kill mechanism. The planet was poisoned with carbon, triggering runaway global warming, which in turn suffocated the oceans and turned them acidic. You have the cause of death. Now you need to find the killer. With the forensic profile of the killer established, a mechanism capable of injecting trillions of tons of carbon into the system, you can now formally identify your suspects. For a crime of this magnitude, there are only two with the means and opportunity. A cataclysm from space, or one from the Earth itself. An asteroid impact versus a planetary-scale volcanic eruption. You begin with the extraterrestrial suspect.
Iridium?
An impact was the culprit for the dinosaurs' extinction, so it's a natural place to start. The calling card of a large impact is clear. A global layer of dust rich in the element iridium, minerals like shocked quartz that are fractured by the impact's intense pressure, and, of course, a massive crater. You methodically search the Permian-Triassic boundary layer for this evidence. You analyze the clay for iridium, but you find no significant spike. The signature that so clearly condemned the dinosaur killer is missing. You search for shocked quartz, and while there are some contested claims, there is no definitive worldwide layer of it. Potential craters have been suggested, but none have been conclusively dated to the boundary or proven to be of impact origin. Furthermore, the carbon isotope data you uncovered in Section 3 suggests a massive release of greenhouse gases that, while rapid, was a sustained pulse lasting thousands of years. A single impact is an instantaneous event. It doesn't align perfectly with the toxicology report. The case against the asteroid is circumstantial at best. You set it aside. You turn to your second suspect, volcanism. You're not looking for a single Mount St. Helens or Vesuvius. You are looking for a large igneous province, or LIP, an event where the Earth's crust splits open and hemorrhages lava on a continental scale for hundreds of thousands of years. Your investigation takes you to the desolate plains of Siberia. There, you find a vast region of volcanic rock known as the Siberian Traps. It covers over 2 million square kilometers, an area larger than Alaska. In places, the lava is miles deep. To understand its scale, imagine the entire subcontinent of India being buried under a kilometer of basalt. You collect samples of this rock and subject them to radiometric dating. The results are undeniable. The eruption began 252 million years ago, precisely at the start of the Great Dying. You have found your weapon, and it is still smoking. The Siberian Traps were not just erupting lava. They erupted through the vast Siberian coal basin, one of the largest deposits of fossil fuels on the planet. This incinerated the coal and baked organic-rich shales, releasing the exact type of light, 12 sea-rich carbon dioxide and methane that your toxicology report identified. The pieces fit. The timing is perfect. The mechanism is clear. You have your culprit. The case is closed. The evidence is overwhelming, the timeline is precise, and the weapon has been identified. You can now stand before the silent boundary in the rock and deliver the verdict. The killer was not from space, it was the Earth itself. The Great Dying was the result of a prolonged planetary-scale assassination committed by the Siberian Traps. Now, you can finally reconstruct the apocalypse, watching as the world you documented in Section 2 is systematically dismantled. It begins in Siberia, with fissures kilometers long splitting the crust, not with explosive cones, but with curtains of fire jetting into the sky. Rivers of incandescent lava, thousands of degrees hot, pour across the land, burying millions of square kilometers and incinerating the vast coal forests. This releases the first pulse of carbon into the atmosphere. Plumes of sulfur dioxide and halogen gases create acid rain so potent it strips leaves from trees and poisons the soil across Pangaea. But this is just the opening act. The colossal injection of CO2 and methane triggers a runaway greenhouse effect. Global temperatures climb relentlessly, perhaps by 10 degrees Celsius or more. The great arid interior of the supercontinent becomes a lethal heat trap, uninhabitable for most large animals. Remember the vast Pangaea Ocean from our crime scene reconstruction? Its sluggish circulation now becomes its doom. As the surface water heats up, it stops sinking, cutting off the oxygen supply to the deep. The oceans begin to suffocate from the bottom up. Anoxic zones spread, creating a toxic aquatic desert where only specialized microbes can survive. Some of these microbes produce vast quantities of hydrogen sulfide, a deadly gas that may have bubbled up into the atmosphere, poisoning the last terrestrial survivors. The vibrant world of the Permian is gone, replaced by a stagnant, searing hothouse. The reign of the synapsids is over. Yet, in the aftermath, in the eerie silence of a nearly empty world, a few hardy survivors emerge. Small, resilient creatures, among them a group known as the Archosaurs. the Great Dying wiped the slate clean, creating the ultimate ecological vacuum. It was this volcanic apocalypse that cleared the path for the archosaurs to evolve, diversify, and eventually give rise to a new dynasty that would rule the planet for the next 150 million years, the dinosaurs. And so, our investigation concludes. We have traveled back 250 million years, sifted through the ashes of a lost world, and identified the forces that brought it to an end. The story of the Great Dying is not just a tale of destruction, but a profound testament to the power of the scientific
This section here
method.
might be part of the leg.
You might be
It
looking at the
is the
articulation
quiet,
here.
patient work of geology and chemistry
This
that
might
gives a
change our
voice to the
understanding of its
silent
locomotion.
rocks, allowing us to reconstruct this planetary crime scene with astonishing clarity. Standing here in the present, we can look back at this ultimate catastrophe and understand that the history of life is written in these cycles of ruin and recovery. We are the beneficiaries of this deep, tumultuous past, living in a world shaped by the fire that nearly extinguished it all, a silent reminder of the fragility and resilience of life on Earth.